Welcome everyone to the Pearson Edexcel GCSE Computer Science Feedback on Summer 2022 Components 1 and 2 event. In the next hour, we're going to cover the overall performance of the components, review the assessment objectives, look at some student responses for both Paper 1 and Paper 2, and we'll finish with a pointer to further support and resources that you'll find useful for the upcoming year. You can find all the documents referred to during this event in your delegates pack. This is the first assessment for the new 2020 GCSE Computer Science specification. Paper 1 is a traditional written examination with 75 marks worth 50% of the qualification. Paper 2, however, is an on-screen examination using the Python programming language, also with 75 marks and worth 50% of the qualification. Both papers are externally assessed. Let's take a look at the assessment objectives associated with this qualification. You can find the breakdown of the 3 assessment objectives for the qualification on page 18 of the specification. AO1 covers recall and understanding, AO2 covers application, and AO3 covers analysis, synthesis, and evaluation in the context of programming. On the same page in the specification, you'll also find the breakdown of assessment objectives by paper. Demonstration of recall and understanding, AO1, is all in Paper 1. Analysis, synthesis, and evaluation in the context of programming, AO3, are all in Paper 2, whereas application, AO2, appears in both papers. Next, we're going to have a look at an overview of the qualification assessments before we move on to look at the individual papers. The provisional grade statistics are published by every awarding organisation and are usually found on their websites. You can find and follow the link here for the Pearson Edexcel's 2022 provisional statistics. For the 2022 series, the computer science statistics are shown in the table. But in short, 75% of students were awarded a grade 4 or above, and 33.8% of students were awarded a grade 7 or above. You can follow the link here for the Pearson Edexcel 2022 published grade boundaries. In general, the performance of the 2 papers was well aligned. Some students gained slightly more marks for Paper 2 than Paper 1, but the reverse was also true. Notably, examiners did see examples of full marks on Paper 2. All of the materials for the 2022 summer series are now available on the Pearson Edexcel website. You can follow the link here. The examiner's reports are the newest items available. You'll find a summary of the question performance, examples of marked student responses, short commentary about how the marks were awarded, and advice for the next examination series. In this section, we're going to look at marked student responses for Paper 1, but remember you can also find others in the Principal Examiner's Report. The 2022 Paper 1 Examiner's Report is included in your pack. The introduction contains a short statement from the Principal Examiner giving an overview of the performance of the paper. The paper assesses AO1 and AO2 as discussed previously. The paper is untiered, meaning that it covers the full range of grades awarded from 9 to 1, and there are questions for all levels of achievement. There are 5 questions in the paper, each focused on a different specification topic, and the 5 questions have sub-questions. Command words are used to indicate the type of questions and responses that are required. A description of the command word taxonomy is found in the specification on page 27. Detailed responses, including examples and reasons, allow students to achieve higher marks. Subject-specific language demonstrates good understanding and will achieve higher marks than generic responses. This question states that a firewall protects a LAN and asks for a description of how it makes this protection work. Some responses, such as the first image, demonstrated confusion between anti-malware or antivirus software and a firewall. The last sentence in the second image clearly describes how the protection works by applying rules to determine what is allowed from one side to the other. This question is an opportunity for students to demonstrate understanding of machine code, assembly code, and direct binary as a programming language. Responses were seen containing the reference to binary as in the first image. Often, students missed the mark for connecting it to machine code. Responses such as the second image gained 2 marks when referring to assembly language. This question requires just a bit more than giving characteristics of an embedded system. The STEM already states that an embedded system is part of a larger machine and that it is different to general purpose computers. Many responses included the characteristic of one single task, but that's just the opposite of general purpose, so could not be awarded a mark. Other correct responses, as here, included low power consumption and small size. The key to this question is the fact that this software is being released to users. The question focuses on vulnerabilities that could be introduced during the development phase. Many responses included the idea of hackers, viruses, or other malware. These would be the result of security vulnerabilities allowing them in. While hackers and viruses do not earn a mark, security vulnerabilities do. Other responses include programming errors, such as syntax or logic errors. These would be due to insufficient testing or bad programming practices, which earns a mark, as in the second image. This question requires responses that describe one way that the operating system allows administrators to manage users. Responses that explain what or who an administrator is could not be awarded marks. Responses that explain the tools or processes that an administrator can use and their effect on the user could be awarded full marks. This question requires analysis of the given addition, identification of the error, and an explanation of why it happened. Literal descriptions, such as the result is 9 bits, did not earn a mark. Responses that just stated an overflow error occurred could, however, be awarded 1 mark. Responses that identified an overflow and then went on to explain the result was too big to store in the bits provided could earn both marks. Question 5b is about a linear search and how to make it more efficient. The input array is sorted, so there are some efficiencies that can be added to ensure the search does not have to look at every item in all cases. Some responses attempted to describe the code in detail, while others described a process to fit the name of the variable passed. There were some very good responses that recognized if the current value being inspected was greater than the target value, then the passed value is used to stop the loop. That means it does not have to inspect all the items to know it's not there. In this question, students had to draw a flowchart based on a problem description. The flowchart symbols are given. One of the common marks lost was because they were hanging symbols. All symbols should have a single output that is connected to the logical flow of the flowchart, making its way to the end symbol. This response is awarded 2 marks as the start and stop symbols are used correctly and the flowchart is fully joined up with no hanging symbols. However, it has not decomposed the problem far enough to deal with all 3 of the possible outcomes. The examiners can provide this advice. Do try and answer every question, as there are part marks available. Read the question carefully. If there is a context, make sure the response is in the same context. 2-mark explain and describe questions need a linked response. Make sure it is not just a restatement of the first point. Examples and expansions can make a response clearer, so do add them. In this section, we're going to look at marked student responses for Paper 2. Remember, you can find others in the Principal Examiner's report. The code file for each of these responses is also provided in your pack. The Principal Examiner's report is included in your pack. The introduction contains a short statement from the Principal Examiner giving an overview of the performance of the paper. The paper assesses AO2 and AO3 as discussed previously. This paper is also untiered. There are 6 questions in the paper. Students are supplied with Python 3 code files. They also have access to a question paper, a programming language subset document, and an integrated development environment of their choice. Students amend, execute, test, and refine their solutions. Each finished solution is saved under a different file name. Centres compress the code file responses and upload them to Pearson Edexcel via the Learner Work Transfer System. In general, questions 1 and 2 on Paper 2 were answered well. A large number of responses were awarded full marks. In question 3, the use of relational operators, data types, and indentation presented challenges for some students. Question 4 was also answered well and often received full marks. Question 5 represented a step up in demand. Many responses included opening and closing the file. It was the reformatting of the linear data to 7 columns per row that presented challenges. In the linear search, question 6, many students were able to write a loop that found an item in the 2-dimensional array. Fewer understood that it could be made more efficient by the use of techniques to force an early exit from the searching. This question requires students to complete or add lines of Python code. Students are told exactly what the lines must do. This example is awarded 6 of the 10 marks available. Integer data types are used, but the conversion of the string, line 15, is missing. As indicated in the Principal Examiner's report, common errors including the use of relational and logical operators. Both these errors are seen in line 20. String concatenation is used. The definition is found in the programming language subset, which students may use in the exam. This question requires students to fix errors and add lines of code in the context of Turtle graphics. The data type of the argument on line 19 is not supplied. As indicated in the Principal Examiner's report, this was not attempted by some students. The 3 runtime errors are all corrected in this response. One of the logic errors has been corrected on line 56. 2 of the required additions have not been attempted. The response does translate and execute. However, the output does not match that given in the question paper. This is the first part of a response that was awarded 5 of the 10 available marks for question 3. It demonstrates how alternative responses were awarded in line with the mark scheme. The code on line 18 results in a real value being stored in circle area. Simple initialization to 0.0 would be fine as well. The formula for the area of a square is given in the paper as s raised to the power of 2, but on line 35, an equivalent is awarded a mark. The requirement for calculating circle area is that exponentiation be used. However, it is not used on line 40. The use of the incorrect relational operator, line 31, and the incorrect variable, line 43, will affect the functionality of this code. This is a response for the Parsons problem that was awarded 12 of the 15 marks available. Lines 13 to 16 show the declarations and initializations moved to the top of the subprogram. line 19 multiplier is not in the correct place. This will impact the functionality of the code. The remainder of the response has been ordered correctly. Executing this code with the data provided in the question would have revealed that the ordering of the subprogram lines is inaccurate. This question relates to processing an array and storing values in a file. This response is awarded 12 of the 15 marks available. The output file is open for writing only. A loop and bounding variables have been used to control conversion of the one-dimensional data to individual output lines. The line feeds have been handled correctly, although there is a comma at the end of every output line and a space after every comma. The design is appropriate, but a few errors in handling the details of the output affect the functionality. This response is awarded 7 of the 15 available marks for question 6. The input has been converted to uppercase and the length of the array is controlling the loop. Two-dimensional indexing is also demonstrated. However, the variable a tile would make a more meaningful identifier than the variable name array. Because it does not stop the loop when the target location is passed over, it does not meet the requirements set out in the question. Use the items in the provided sort code. There may be marks associated with their correct usage. Executing the code in the IDE will show where the syntax and runtime errors are. In some questions, there may be marks for just getting the code to translate. This is particularly important with the level-based mark schemes. Execute the code to make sure the outputs match the requirements. Testing the code with the data provided in the question will immediately inform students about the accuracy of their program. If the indicated results are not reproduced, then the student's code still has errors. Using time effectively is key to accessing all the marks in this paper. Students don't need to worry about validation of inputs unless it is explicitly set out in the question. Before we finish, we'll take a look at some of the support and resources that are available to you. All of your students' results are available for you to see. You will need access to the Results Plus system, but you can ask your exams officer to arrange that for you. If you have not already registered, then we suggest that you do. For paper 1, each specimen includes a question paper and a mark scheme. For paper 2, each specimen includes a question paper, a programming language subset, and Python code files that the student will use to complete the paper. For paper 2, there is also a mark scheme and Python code files for the code shown in the mark scheme. For each question in a specimen paper, you can find pointers to more information about that specification point. This might be in the PLS, the Good Programming Guide, the textbook, or the scheme of work. For each question, there are at least 2 student responses. There is a mark commentary detailing where the marks have been awarded and why. Additional information is provided that might include hints and tips for approaching this type of question or further information associated with the code. Paper 1 is being included as part of the upcoming mock service. However, paper 2 will not be included. As a centre, you're always welcome to get in contact with the mock service to find out about the latest details. Finally, the first place to look for information about computer science is the subject-specific page on the Pearson website. Here you'll find information about Tim Brady. He's the subject advisor, and I'm sure he'd love to hear from you about any queries or questions that you may have. Additional links to the course materials and the teaching support training materials can also be found here. That just leaves me to thank you for taking the time to find out more about the Summer 2022 Pearson Edexcel GCSE Computer Science Assessment.